Hey guys, this is Mr. Moog. I'm going to take you through the ratio test with a lesson and then a couple examples. Hopefully this will be a pretty quick video. So ratio test for us was in Unit 8, Day 4, and College Board's going to reference it as 10.8. The majority of what the ratio test is doing is determining the convergence or divergence of a series. So here you can see if we have a series a sub n and the limit of its ratio of consecutive terms, a sub n plus 1 over a sub n, granted it's the absolute value of that ratio, has a value, then there's three conditions that can happen. So if that value is less than 1, then the series converges. If the value of the limit is greater than 1, then the series diverges. And if the value of the limit is 1, then it's inconclusive. So this test is pretty cool in that it tells you whether it converges, diverges, or in one specific case, it doesn't actually tell you anything. Some things to note is that this test works really well with factorials and exponentials. I would tend to pretty much go straight to this test if I see factorials and exponentials in the same sequence or series. Alternating series also work with ratio test. I would say ratio test would be my second option here. So if I have an alternating series that doesn't have factorials and exponentials, I would try the alternating series test. Both tests are on the exam this year, so both of them are good to know. And then when is it not good to use? I mean, the first two, pretty obvious. If you have a geometric series, use geometric series. If you can recognize you're doing too much work if you're doing the ratio test. The P series, also something you should be able to recognize you're doing way too much work if you have to use the ratio test. But then this last condition here, you'll see some examples of what polynomials look like. So what I mean is if you have a rational that the top is a polynomial and the bottom is a polynomial, and there aren't factorials or exponentials, then it's probably a good bet that it's not going to work or give you an inconclusive result. So you might see something like L equals 1 at the end. So that's just a quick rundown of what the ratio test says. Let's actually get into a problem with it. So the first example says, which of the following series converge? And so we've got option 1, option 2, and option 3. The first series is from 1 to infinity, and it's 8 to the n over n factorial. Top is an exponential, the bottom's a factorial. This is like the ideal candidate for the ratio test. We're going to use it on that. Second one is n factorial over n to the 100, so factorial on the top. And this, in my opinion, would be a polynomial on the bottom, so not the best, but we're still going to try the ratio test there. And then the bottom, the third one, I'm actually going to talk about first. This is n plus 1 over n times n plus 2 times n plus 3. This is that last case that I was mentioning of when not to use the ratio test. Polynomials. We only have polynomials here. My preference would be to do the comparison test. And so essentially this series could be rewritten as n, not essentially equal, I'll put an arrow because it's not equal, over n times n, which would be n to the third. So the way I would want to compare this to something would be simplifying that rational, n over n to the third, and I would want to compare my original n plus 1 over n times n plus 2 times n plus 3 to this series at the end here. The reason I want to compare to this is because this is a P series that I know converges. So I'm going to do the ratio test to show you why I would prefer to do a comparison here. But that's just something to recognize that the ratio test is probably not your best bet here. So ratio test tells us we need a sub n. So I'll just pull that out. And then we also need a sub n plus 1. So I will write that. All we're doing is substituting in n plus 1 for all the n's. So on top we get n plus 2. On the bottom we get n plus 1 times n plus 3 times n plus 4. What we're now going to do is we're going to take the limit as n goes to infinity of the absolute value of the ratio of a sub n plus 1 and a sub n. I'm going to multiply a reciprocal, so instead of writing a sub n, I'm just going to multiply by the flip of that. So I'll put a sub n plus 1 as it's written, and then I'm going to multiply by the flip of a sub n. So n plus 1 goes on the bottom, and then the top is n times n plus 2 times n plus 3. So you can see immediately this is not the best limit to look at because we don't have much to cancel here. So limit as n goes to infinity. If I wanted to work through this, I always want to try and simplify what I can, but all I can simplify is n plus 3 on the top and the bottom. So if I rewrite this limit, I get the absolute value of, I have n plus 2 and n plus 2, so I'm going to put n times n plus 2 squared, and on the bottom I have n plus 1 and n plus 1, so I'm going to put n plus 4 times n plus 1 squared. Well, we're in a limit and we're going to infinity, so what we really want to think about is the degree of the polynomial on top and the degree of the polynomial on the bottom. Since I have an n and an n with a degree 2, my degree on top is 3. Same thing happens on the bottom, even though it's n plus 4, it's still 1, and then a degree 2 here. So the degrees actually match. So it's really, if we did L'Hopital several times, we would get that the limit is the ratio of coefficients. There are no coefficients in front of n, so the limit just goes to 1. Unfortunately, that's the one inconclusive case. Wow, I spelled inconclusive really wrong there. Inconclusive case for the ratio test. So this, I'm starting with the bad example, is not what we want to use the ratio test on. We want to use it on factorials and exponentials mostly. That's why I mentioned at the very beginning, I would start with a comparison to this series, and by limit comparison or direct comparison, you could find that both series converge. I'm not going to go through those steps because the comparison tests are not on the AP exam. So you could be asked a question that ended in an inconclusive ratio test. You will not be asked a question that talks about limit comparison. So now that we've seen the bad example, let's go to the best example. I'm going to do number 1. The sum from 1 to infinity of 8 to the n over n factorial. I'm going to pull out a sub n and a sub n plus 1 again. 8 to the n over n factorial, that's my a sub n. 8 to the n plus 1 over n plus 1 factorial. So this one's going to be really nice to work with. If I take the limit as n goes to infinity of the ratio of a sub n plus 1 over a sub n, I'm just going to write it again with a sub n plus 1 multiplied by the reciprocal of a sub n. But the other thing you can see I'm doing right here is I'm expanding the exponential and I'm expanding the factorial as I write it into the limit. You're totally okay to do that. So 8 to the n plus 1 just becomes 8 to the n times 8, and n plus 1 factorial becomes n plus 1 times n factorial, because it's all the consecutive numbers below multiplied together. So a sub n as a reciprocal puts n factorial on top and 8 to the n on the bottom. And now we just cancel. N factorial and 8 to the n both cancel each other out. We get the limit as n goes to infinity simplifies to 8 over n plus 1. And that limit to infinity is just 0. The way we can say that relates to 1 is that 0 is less than 1, which is a good thing, because that means this series converges. So far 1 and 3 have both converged. Granted, 3 wasn't through ratio test, but we are trying to find all the series that converge. So 2 of the 3 that we've tested have converged so far. Well, 2 of the 2 that we've tested have converged so far. Let's test the third one. So the sum from 1 to infinity of n factorial over n to the 100. Like I said, the factorial is good. N to the 100s should be some alarm bells for you. So let's see what happens here. My a sub n doesn't change. My a sub n plus 1 changes into n plus 1 factorial over n plus 1 to the 100. So not ideal to have n plus 1 to the 100 power right there. I'm not going to expand that polynomial because it would take me a really long time, but you can see already some issues there. The limit as n goes to infinity of the ratio or the multiplication of the reciprocal is n plus 1 times n factorial over, and I can't expand n plus 1 to the 100, so it's going to stay. So I expanded the factorial but did not expand the polynomial. Multiply by the reciprocal and you get n to the 100 over n factorial. And now we have the factorials cancel, and that's it. N plus 1 to the 100 and n to the 100 don't cancel, nor can you make them cancel easily. So my limit simplifies as n plus 1 times n to the 100 over n plus 1 to the 100. There's a couple things you can do or realize at this point. You can realize that you have more n's on top because there's an n here, an n to the 100 right there, and on the bottom all you have is an n to the 100. From there you might recognize this limit's going to go to infinity. The other method you could realize is that you have an n plus 1 with a power of 1 on it and an n plus 1 with a power of 100 on it. They're on opposite sides of the fraction, so we subtract. That's the method I'm going to use so that I can clearly show that the power on top is bigger than the power on the bottom. 100 is bigger than 99, so this limit is going to infinity. So that's greater than 1. Therefore, this series diverges and is not a convergent series. So like I said, polynomials not your best friend with the ratio test, but 1 series for letter 1, number 1, is ideal, and then the third one not so ideal at all, but it still does converge. Moving on to another example, example 2, we have which of the following series converges for all real numbers x. So this one I wanted to talk about because it gets at the idea of an interval of convergence, but it's not actually asking you to find the interval of convergence. It's asking you to think logically through a problem. And so you could see a question like this on the AP exam, even though the interval of convergence is not something that'll be tested this year. So what I mean by thinking logically is if something converges for all real numbers of x, then you could theoretically plug in any x value into any of these series, and the series would still converge. So let's just do a test real quick. Let's pretend that x is 4. Now the series from 1 to infinity of 4 to the n over n, well, that's going to grow really fast on the top and not as fast on the bottom. So this is really big on top, so technically by the nth term test, this diverges for x equals 4. Well, if it diverges for any value, then it doesn't converge for all real numbers, so A is automatically out. B, let's use the same number, 4, still growing exponentially on the top, and on the bottom, it's only a quadratic. Well, exponentials grow faster than quadratics, so this diverges for n equals 4. The ratio test can prove this if you want to do it, but it's really a question of do you understand what's happening here without actually performing all of the work. C, same thing, except it grows even smaller on the bottom. So plug in 4 for x, it's an exponential on top, and on the bottom it's a square root. That's going to diverge as well for n equals 4. So A, B, and C are out. Don't even bother doing the ratio test on them because you plugged in an x value and you found it doesn't, oh, I said n for B and C, I meant x equals 4. It diverges for at least one x, therefore it doesn't converge for all real numbers of x, so it's out. So D and E are the last two that we're going to look at, and it's nice because we have an exponential and a factorial. We just got to figure out which one has the exponential and factorial in the correct spot. So for D, we have a sub n equals e to the n x to the n over n factorial. Yes, it's totally okay to keep an x in there, even though power series aren't necessarily on the exam. They could ask a question like this. They might put a k and say that k is some constant, but being able to do problems like this, you should be able to do it for the AP exam this year. A sub n plus 1 is e to the n plus 1, x to the n plus 1 over n plus 1 factorial. Putting that together in my limit, as n goes to infinity, we have e to the n times e times x to the n times x over n plus 1 times n factorial. That's a sub n expanded. Now I'm going to multiply by the reciprocal. Sorry, that's a sub n plus 1 expanded. I apologize. And now I'm going to multiply by the reciprocal of a sub n. So n factorial over e to the n times x to the n. This limit simplifies nicely because of the factorials and exponentials. So e to the n cancels, x to the n cancels, and n factorial cancels, leaving us with just ex on top over n plus 1 on the bottom. Well, this limit's going to infinity, but it's n to infinity. So e and x are essentially constants. So as the constants on top don't change and n moves to infinity, this limit goes to 0. That's less than 1, so we know it converges. So far, A, B, C are out. D is the only one that we've tested that converges, so we're going to hold on to that one as most likely being our answer. If you remember interval of convergence stuff, you'll remember that when the x stuff goes away and you end up with 0, that's telling you that it converges for all real numbers. E follows similarly. Sorry for the messy writing right there. A sub n and a sub n plus 1 look pretty close to each other from the previous problem, but they flipped the exponential and the factorial there. So my limit is going to have pretty much the same thing except a couple pieces flipped around. So n plus 1 times n factorial times x to the n times x over e to the n times e times e to the n over n factorial x to the n. So I know I wrote all that stuff quickly, but it's pretty much the same looking as the blue, as part D, except the factorial and the exponential have changed places now. So you can see what that limit looks like. Now we can go ahead and cancel e to the n factorial, and x to the n all cancel once again. This time our limit simplifies to n plus 1 on top times x all over e. Well, now the n is on top, and all we're doing is the limit to infinity of n. So this limit goes to infinity, which is greater than 1. Therefore, we know this actually diverges for all x not equal to 0, because our center here would be 0. So E is also out, leaving us with just D as our final answer. So the ratio test is a great test. I think it works really nicely. It gets you some nice results. Hopefully it's still fresh on your memory and you are good to go with using it. I hope this lesson was helpful and you have a great day.